Hey everyone, and welcome back. Ready for another deep dive?
Always.
Well, today we're looking at something pretty major happening over at the Karlsruhe Institute of Technology. KIT.
Yeah.
They're joining forces with the Institute for Quantum Science and Technology.
IQST. Yeah, I've been following this. It's big.
Yeah, we've got a whole stack of articles and reports here. Seems like everyone in the quantum world is buzzing about this.
Makes sense. Think about it. You've got KIT, 10,000 employees, almost 23,000 students.
Wow.
And they're known for being so research-focused.
Yeah, real commitment to innovation.
Uh-huh.
And IQST.
Oh, they're incredible. They're like this hub for all things quantum science.
Right.
Super interdisciplinary, too. Their whole mission is about turning that science into tech we can actually use.
Okay, so we've got this research powerhouse teaming up with a quantum science hub.
And they both already have these massive networks, so yeah, it's huge.
What really strikes me, though, is just how many different fields are involved. Natural sciences, engineering, even life sciences. It's like they're building this quantum dream team.
Mm-hmm.
What aspect are you most excited about?
I think, for me, it's got to be the real-world applications. We're not just talking theories here.
Yeah.
This could lead to real changes in, telecommunications,
Healthcare.
finance, even.
All areas that, really impact us, in our day-to-day lives.
Exactly.
And we know KIT is already great at that whole turning research into reality thing.
Yeah, for sure.
They've worked with some big names, ABB, BASF, IBM.
Oh, yeah, they're not afraid to get practical.
Plus, they're setting up this joint steering committee with KIT's executive board to make sure they're hitting those goals, not just research goals, but goals that actually benefit society.
That's what I love about this. It's not just about publishing papers.
Mm-hmm.
They want to make a difference. And that's where IQST comes in too, right?
Yeah.
Bridging that gap between all the amazing work in academia and what actually makes it out into the world.
And this all ties into that Quantum W initiative, doesn't it? The one here in Baden-Württemberg.
Yes. Quantum W is all about creating that ideal ecosystem for quantum research and development here in the state.
So is this partnership a major boost for that whole initiative, do you think?
Oh, absolutely. It brings together these key players,
Mm-hmm.
resources, expertise. You can't beat that shared vision they have, focused on those big societal challenges.
And we know KIT is really taking those challenges seriously, especially the ethical side of things. They're not just diving in head first.
Yeah.
They have that multi-stage technology assessment thing they do, right?
Oh, yeah, they're super thorough. Literature reviews.
Talking to all sorts of people to get their input.
Mm-hmm. Stakeholders, ethicists even,
Yeah.
policy folks.
It's really impressive. It shows they're in this for the long haul, not just for the quick, flashy results.
Absolutely. And they're not just researching either. They're training the next generation.
Oh, right. The joint degree programs.
Workshops.
Internship.
They're really preparing these students to, be leaders in all this.
Wow. Okay. So we've got this powerful partnership,
Yeah.
a commitment to real-world solutions, a responsible approach to development, and they're thinking about the future.
Uh-huh.
This is exciting stuff,
It really is.
but there's a lot more to unpack here.
Oh, yeah. Tons.
So many questions to answer. Get ready to dive even deeper after the break.
Can't wait. We really have only scratched the surface here. There's so much more to unpack with this partnership.
I know, right? It's like the deeper we go, the more fascinating it gets. One thing that's really caught my attention is how they're approaching the whole idea of understanding quantum systems.
Oh, yeah?
I know IQST has been working on this new interdisciplinary approach.
Uh-huh.
So what does that actually look like?
Okay, so imagine you've got physicists, chemists, engineers.
Even biologists, I read.
Yeah,
Yeah.
all working together, right?
Yeah.
To look at these quantum systems. But from all their different perspectives, it's not just one narrow view anymore.
So it's like getting this multi-dimensional understanding.
Exactly. And that's where Kiki's expertise comes in, right?
Yeah.
They're doing some really cool stuff with molecular qubits.
Oh yeah, I remember reading about that.
Really pushing the boundaries there.
I remember from our earlier deep dives that qubits can be so finicky.
Oh, tell me about it.
Super sensitive, hard to work with. So what makes KIT's approach to these molecular qubits different?
Well, think about a qubit built from a single molecule.
Okay.
That's basically what they're doing, right? And those molecular qubits, way more stable.
So they're not as easily disturbed by their environment, all that noise that can mess things up.
Exactly. And over at IQST, they're doing great work with superconducting qubits.
Okay.
They're working at these super low temperatures.
Yeah, I read that.
And they've developed some new fabrication techniques that are making the qubits much more reliable.
So it's almost like they're each tackling this qubit challenge from different angles.
Exactly. And that kind of collaboration, it can lead to breakthroughs that neither one could achieve on their own.
It makes sense. And it's not just about the hardware, right? They're also collaborating on developing new quantum algorithms.
Oh, absolutely. Can't forget the software.
Right. Those algorithms are what tell the quantum computer what to actually do.
It's like building a car, right? You need a powerful engine, but you also need a skilled driver.
I like that. The quantum computer is the engine, the algorithms are the driver.
Exactly.
So they're working on both, right? The hardware and the software. But they're still keeping those real-world applications in mind.
That's the key. It's not just building a quantum computer for the sake of it. It's about finding ways to use this amazing technology to solve real problems.
In medicine, materials, even finance. It's like we're talking about revolutionizing entire industries.
Right.
But we can't forget about quantum communication, right? I know that's another big area where they're joining forces.
Oh, absolutely. Quantum communication is all about transmitting information securely, like fundamentally secure. We're talking unhackable.
Hold on, wait, seriously, how is that even possible?
Quantum mechanics, it's like a whole different set of rules.
Right.
For example, have you ever heard of entanglement?
Entanglement.
Yeah.
Yeah, that sounds like something out of Star Trek.
I know, right? But it's real. And it's a core principle in quantum communication. Imagine you have two particles that are linked. No matter how far apart they share the same fate.
Okay.
Change one, and the other changes instantly.
That is wild. Okay, so how does that actually make communication secure?
Well, if you use those entangled particles to transmit information, right, anyone trying to snoop or intercept that communication, it disrupts the entanglement.
Ah, so both the sender and the receiver would know that something was up.
Exactly. It's like an unbreakable seal.
Incredible. Okay, so what are KIT and IQST focusing on specifically in this area?
Well, they're developing new quantum communication protocols, the rules for transmitting that quantum information. And they're looking at how to use entanglement to create those channels that can span, like, huge distances.
So maybe someday we can have this completely secure network connecting people and information all over the world.
That's the goal. And that's just one piece of what this partnership could achieve. I mean, they're really pushing boundaries here.
It is amazing. I feel like we've learned so much, but we've only just scratched the surface of this partnership's potential.
Oh, there's always more to discover. The quantum world is full of surprises.
And with these two powerhouses working together, who knows what breakthroughs they'll make.
Right. It's like they're building this, like, quantum innovation hub right here.
And the whole world is watching.
Definitely. Okay, but before we get too lost in all the excitement, remember earlier when we touched on the ethical side of things?
Oh yeah, KIT's approach to responsible development.
We should dig a little deeper into that, I think.
I agree. It's important. So, how is KIT approaching this issue? What are they actually doing to make sure they're developing this technology responsibly?
They've got this dedicated team, right? Their whole job is to assess the ethical and societal impact of the work.
So it's not just about the science, it's about the bigger picture.
Exactly. They're looking at, like, the potential consequences for all of us.
I bet that's a huge undertaking. What does their assessment process actually look like?
It's multifaceted, literature reviews, stakeholder engagement.
So they were talking to people from all different backgrounds.
Absolutely. Ethicists, policy experts, they want to hear all the different perspectives.
It sounds like they're taking this seriously. It's not just like a box they have to check.
Oh, no, they get it. They understand that quantum tech has huge implications, and they want to make sure those implications are positive for everyone.
That's reassuring to hear. It's like they're not just trying to build a quantum powerhouse, they're trying to build it responsibly.
Exactly. And that sets a really great example, for other institutions, researchers around the world. It shows that thinking about the ethics of it all, that needs to be a core part of scientific progress.
I love that. This is all so inspiring. I feel like we've covered so much ground, but we haven't even touched on those specific research initiatives yet.
Oh yeah, we're just getting started. Get ready for another deep dive. We're about to explore the cutting edge of quantum science and technology.
I can't wait. Let's jump into those exciting research initiatives. Okay, so those research initiatives. What are some of the areas where KIT and IQST are really teaming up?
Well, quantum computing is definitely a big one. Both institutions are working on developing new types of qubits, those quantum bits we were talking about.
And we know those can be a bit tricky to work with, right?
Yeah, super sensitive. They're easily affected by their surroundings, which makes them hard to control. But both KIT and IQST are doing some impressive things to overcome those challenges.
Okay, so what are they doing? What's their approach?
Well, KIT is focusing on molecular qubits,
Molecular qubits. Break that down for me. What are those and why are they so important?
Think of it like this. Imagine a qubit that's built from a single molecule.
Whoa.
That's basically what they're working on. And these molecular qubits, they have the potential to be much more stable than other types.
Ah, so they're less susceptible to all that noise from the environment that can mess things up.
Exactly. And over at IQST, they're focusing on superconducting qubits.
Okay.
They operate at these incredibly low temperatures.
Yeah, I remember reading about that.
And they've come up with some really cool fabrication techniques to boost the performance and reliability of those qubits.
So it sounds like they're kind of tackling this qubit challenge from two different angles.
Right. And that kind of collaborative approach, it could really lead to some major breakthroughs, breakthroughs that neither one could achieve on their own.
That makes sense. Teamwork. And it's not just about the hardware, is it? They're also working together on quantum algorithms.
Oh, yeah, definitely. The software is just as important.
Right, because the algorithms are the instructions. They tell the quantum computer what to do.
Think of it like this. It's like building a race car. You need a powerful engine, but you also need a skilled driver to win the race.
Ooh, I like that. So the quantum computer is the powerful engine, and the algorithms are the expert driver.
Exactly. And you need both to really make things happen.
I see. So they're working on both the hardware and the software side of things. And all the while, they're keeping those real-world applications in mind.
That's a big part of it. It's not just about building a quantum computer for the sake of it. They're looking for ways to use this amazing technology to solve real problems.
Like in medicine, material science. I even read about potential applications in finance. It's mind-blowing to think about the possibilities.
Okay.
But we have to talk about quantum communication, right? That's another big area they're collaborating on.
For sure. And quantum communication, that's all about transmitting information in a way that's totally secure. Like truly unhackable.
Unhackable. Really? How is that even possible?
It all comes down to quantum mechanics. It's a whole different world, you know? Things work very differently at that level, like entanglement, for example. Have you heard of that?
Entanglement. Yeah, it sounds pretty sci-fi.
Right. But it's totally real. And it's actually one of the key principles behind quantum communication. Imagine two particles that are linked together. No matter how far apart they are, they share the same fate.
Okay, I'm trying to picture this.
So if you change one of those particles, the other one changes instantly, even if they're miles apart.
Whoa, that's wild. So how does that make communication secure?
Okay, so imagine you use these entangled particles to send a message, right? Anyone trying to eavesdrop or intercept that communication would immediately disrupt that entanglement.
Oh, I see. So it's like an alarm system. Both the sender and receiver would instantly know that someone was trying to snoop.
Exactly. It's practically impossible to hack.
That is incredible. Okay, so what are KIT and IQST actually working on in this area?
They're developing something called quantum communication protocols. Basically, these are like the rules of the road for how you transmit quantum information. And they're also working on how to use entanglement to create communication channels that can span like really long distances.
So we're talking potentially connecting people and information all over the world in a way that's completely secure.
That's the idea. It's a pretty exciting area of research.
It's all so amazing, honestly mind-blowing. This whole partnership between KIT and IQST, it really feels like they're on the verge of something truly groundbreaking.
It really does, doesn't it? They're pushing the boundaries of what we thought was possible.
It's been an incredible journey exploring all of this with you.
I agree.
For our listeners, as we wrap up our deep dive today, what are the key takeaways you want them to remember about this partnership?
Well, first and foremost, KIT and IQST, they're leading the charge in quantum research. They're not just talking about the future, they're building it.
And they're not just focused on building fancy technology for the sake of it, right? They're looking at how to use it to solve real-world problems and improve people's lives.
Absolutely. Whether it's developing life-saving medical treatments, designing brand new materials, or securing our communications, this partnership has the potential to make a real difference.
This has been such a fascinating deep dive. It's inspiring to see all the amazing things happening in the world of quantum science and technology. I can't wait to see what breakthroughs come next. Thanks for joining us on this incredible journey, everyone. Until next time, keep exploring.